Jupiter's moon Io is often described as the most geologically active body in the solar system. With its volcanic landscape, extreme temperatures, and constant bombardment of radiation, Io presents an environment that is as fascinating as it is hostile. In this exploration, we'll delve into the unique characteristics of Io, the latest imaging advancements, and why this moon is truly a hellish world. Io is the third largest of Jupiter's 79 known moons and is one of the 4 Galilean moons discovered by Galileo Galilei in 1610. It orbits Jupiter at a distance of about 422,000 kilometers, about 261,000 miles, and has a diameter of approximately 3,643 kilometers, about 2,263 miles, making it slightly larger than Earth's moon. The unique characteristics of Io stem primarily from its intense volcanic activity, which is driven by gravitational interactions with Jupiter and its other moons. Io is home to hundreds of active volcanoes. Some of the most famous, like Mount Loki and Pele, have erupted numerous times, spewing sulfur and sulfur dioxide into the atmosphere. The eruptions can reach heights of up to 500 kilometers, 310 miles, and create large lava lakes. The surface is dotted with calderas, large volcanic craters formed by the collapse of land after a massive eruption. The lava flows on Io are primarily composed of silicate rock and sulfur, resulting in a colorful and varied landscape. The constant pull of Jupiter's gravity creates tidal forces that lead to tectonic movements on Io. This activity causes the surface to crack and shift, leading to the formation of ridges and valleys. Io's atmosphere is extremely thin, composed mainly of sulfur dioxide, with traces of other gases like sodium and potassium. The thinness of the atmosphere means that Io cannot support life as we know it, and the extreme temperatures can drop to -130 degrees Celsius, -200 degrees Fahrenheit, in the night. The atmosphere is also influenced by volcanic activity. When volcanoes erupt, they can release plumes of gas that rise high into the tenuous atmosphere, reaching altitudes of over 300 kilometers, about 186 miles. These plumes can also create temporary pockets of gas around the moon, but they dissipate quickly due to the lack of atmospheric pressure. One of the most dangerous aspects of Io is the intense radiation it experiences. Io orbits within Jupiter's powerful magnetosphere, which traps charged particles and creates a highly radioactive environment. The radiation levels on Io are far greater than what is found on Earth. In fact, they are so high that a human would receive a lethal dose within just a few days of exposure. The radiation bombards the surface of Io, causing chemical reactions that alter the composition of the materials found there. This can result in the darkening of certain areas and changes in the color of the surface. The intense radiation also contributes to the loss of Io's atmosphere. Charged particles can strip away gases, preventing them from accumulating to a more substantial atmosphere. Any future missions to Io will need to consider the radiation environment, requiring robust shielding for spacecraft and technology that can withstand the harsh conditions. Juno's JunoChem instrument has captured high-resolution images that reveal Io's surface features in stunning detail. The images show volcanic plumes, surface textures, and the varied coloration of the landscape. The spacecraft has documented the activity of volcanic plumes, providing valuable data on their height, composition, and frequency. These observations help scientists understand the dynamics of volcanic activity on Io and its implications for the Moon's geology. Juno has also collected data on Io's magnetic field, helping researchers understand the interaction between the Moon and Jupiter's magnetosphere. This information is crucial for comprehending the Moon's geological processes and its atmosphere. Research into extremophiles, organisms that thrive in extreme conditions, on Earth can offer clues about potential life forms that might exist in similar hostile environments elsewhere in the universe. While Io's environment is incredibly harsh, understanding how life can adapt to extreme conditions can inform our search for extraterrestrial life.